Well, hey there, Algebra 2 class. We are on section 4.7, which is the quadratic formula. I believe that we have seen this formula before in Miss G's class a while back. It is highlighted here for you in the text. Sorry, it's not highlighted, it's highlighted in the video. But you have it right here on your packet of notes. If you have the equation in the form ax squared plus bx plus c equals 0, we're back to an equals 0 thing again. If that's true, then the number in front of the x squared, the plane x, the constant, those are your a, b, and c. And we also have the discriminant. The discriminant is just the what's underneath the square root, which is kind of an important number because if it's positive, that means things are going to work with this. If they're negative, well, you can't take the square root of a negative number, can you? Can you? So anyway, we can explore some of that. But the reason that the quadratic formula is useful and necessary as well, if you graph these equations, sometimes they intersect the x-axis in irrational spots, which means you can't factor it. Now, you could use completing the square like we learned in the previous video, but if you have numbers in front of the x squared, you do not want to use completing the square. So the completing the square process can be done with the a, b, and c, and we find out that the solution is actually the quadratic formula. So we could just dump the a, b, and c into that quadratic formula and get our solutions. So it works out pretty nicely. So in fact, let's work through this first one. I'm going to zoom in quite a bit, and you've also got the answer key worked out as well. You notice this is not set equal to 0, so I need to move the 2 over so that I have 5x squared minus 2x minus 2 equals 0. And I'm going to label specifically what my A, B, and C are. I know my A is 5, my B is negative 2, and so is my C also negative 2. So now I can use the formula, and I'm going to write it down. X equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Now I can dump the numbers into that formula. So I have the opposite of b is negative 2, plus or minus the square root of b squared, that's negative 2 squared, minus 4 times a times c, all divided by 2a. So now I've dumped the numbers into that formula, and now I can do a whole bunch of simplification. The negative 2 squared is 4. A negative 4 times a 5 is a negative 20, so it's minus 20, but a minus 20 times a minus 2 is a positive 40. So this becomes the opposite of negative 2 plus or minus x is going to equal 2 plus or minus, this is what I say, 4 plus 40 divided by 10, which is going to be 2 plus or minus the square root of 44 over 10. This is not simplest form. It absolutely is not. There's a factor of a perfect square root. It's a perfect square 4 that can be factored out of there, and we can do the Valentine's. Hard to separate those into two things. For the sake of our understanding at this point, let's call this good, and we will talk about the radical simplification in chapter 6. So that's how this process works. You can look at the notes to see what I did here. Probably distributed through, moved everything over, and used the quadratic formula pretty nicely. All right, let's look at this right here. Let's say that I want to apply the quadratic formula in a word problem situation. Your company sells widgets. The profit gained by selling widgets at X dollars per widget is given by this right here. The profit equals this. What is the lowest cost per widget that should be charged to make a profit of $1,500? Does that mean, am I asking, or if I'm being asked, when is the profit equal to $1,500? So really, I want to solve this. Well, let's just subtract $1,500 from both sides and then use the quadratic formula from there. Can you use graphing for this? Yes, you absolutely can use graphing for this. Could you divide everything by things to get the numbers simpler? Yes. Yes, you can. Check the answer key, email me with questions on that one. Let's continue on with using the discriminant. I've got a really nice table that you can see in the notes page where if you have the square root of a negative number, well, there's no real solutions. If you have the square root of 0, then there's one solution, and it's rational. If you have the square root of a perfect square, then you have 2 rational solutions. And if you have the square root of a not perfect square, then you have 2 irrational real solutions. So that means what I can do then is simply look at the b squared minus 4ac. Not the square root, not opposite of b plus minus the square root divided by just the part under the square root. And if I look at just the part under the square root, I can determine how many real solutions there are going to be. In this right here, this equation turns into 2x squared minus 3x plus 7 equals 0. And my a then is 2, my b is negative 3, my c is 7. And I can put those numbers into the discriminant to see what kind of solutions I have. So b squared, negative 3 squared, minus 4 times a times c. This right here is 9 minus, what is that, 8 times 7, 56. 9 minus 56, let's see, wouldn't that be 47? So I believe I have 47 negative. So that means my discriminant is negative. My discriminant is negative, then that means no real solutions. And that's how you can process through that. I believe that is pretty much all there is with this set of notes. We could continue on with this. I'll let you look at the notes to see how that works. And perfect, that takes us to section 8. All right, that's it. See you in a bit.